Hello and welcome to the Unit 8 Section 3 video on angles and circles. So we're going to find out how to find the measure of arcs and inscribed angles when we are dealing with circles here, because you're not always going to have a central angle to be able to determine the measure of an arc. What if we have some other information? So let's start off by talking about what an inscribed angle is. It's an angle whose vertex is on a circle and whose sides contain chords of the circle. An intercepted arc consists of the endpoints that lie on the sides of an inscribed angle and all the points in the circle between them. So here we have our inscribed angle, and then the arc that is intercepted by that angle, that inscribed angle. This is the intercepted arc. A chord or arc subtends an angle if its endpoints lie on the sides of the angle. So DF subtends angle DEF. That term is not going to be quite as important as inscribed angle and intercepted arc. So what we're talking about here is DF and the relationship it has with inscribed angle DEF. So what is that relationship? Well, the measure of an inscribed angle is half the measure of its intercepted arc. So here we have an angle that is created by a diameter and a chord, and AC, if you take AC and take half of it, you get the angle ABC. This can be just two chords that don't go through the central angle. It could also be two chords that are on one side of the center of the circle. So in all three of these cases, you use the same formula. Half of the arc measure is the angle measure for your inscribed angle. So let's do an example. So in example 1 here, we're going to find the measure of RST and the measure of arc SU. So for the measure of angle RST, we know that that's going to be 1/2 of the arc that it intercepts. So RST is here, and so the intercepted arc is RT. So the measure of RT, our intercepted arc. Well, our intercepted arc here is 120 degrees. So 1/2 of 120 degrees is 60. So that is the measure of angle RST. For the measure of SU, well, SU is here. SRU is our corresponding inscribed angle. So the measure of SRU is going to be 1/2 of the measure of arc SU. Well, we know that SRU is 40 degrees, and we have 1/2 of what we're looking for, measure of SU. Well, if we multiply each side by 2, you get the measure of arc SU is 80 degrees. Now, we have a corollary that stems off of this, and the inscribed angle corollary states that if inscribed angles of a circle intercept the same arc or are subtended by the same chord or arc, then the angles are congruent. So in other words, here we have we have 3 inscribed angles, ACB, ADB, and AEB. All 3 of these angles are congruent because they intercept the same arc. And so all 3 of these angles are going to be half of the measure of AB. So knowing that, let's determine what the measure of DEC is, which is this angle right here. So if we know that AD, arc AD, is 86 degrees, we are going to use that to determine the rest. Okay, so let's start off with what we know. We know that the measure of BAC is going to be the same as the measure of BDC because they intercept the same arc, which is BC. So the measure of BAC is equal to the measure of BDC DC. So since BAC is 60 degrees, then the measure of BDC also has to be 60 degrees. Okay, so that gives us BDC. So that gives us this angle right here. Now, what about finding ECD or ACD? Well, the measure of angle ACD is equal to 1/2 of the arc it intercepts, which is AD. And that would be 1/2 of 86 degrees, which would be 43 degrees. So now we know, in this triangle, we know what the measure of angle D is, we know what the measure of angle C is. All that's left to find is what the measure of angle E is in this triangle, which is DEC. So we use the triangle sum theorem. The measure of DEC plus the measure of the other two angles in that triangle, 60 degrees and 43 degrees, has to equal 180. So if you add those two angles together and subtract them from 180, you get that the measure of DEC is equal to 77 degrees. So you have to kind of follow the breadcrumbs a little bit, but you can use a lot of these new things that we're learning to find what we're looking for. All right, how about finding angle measures in inscribed triangles? An inscribed angle subtends a semicircle if and only if the angle is a right angle. So if we have two chords that intercept a semicircle, then we have created a right triangle. So let's look at this in some examples. In this first example, we're just simply going to find x. Well, we know that the measure of angle RQT is equal to 90 degrees. Well, we also know it's 4x plus 6. So 4x plus 6 equals 90. Subtract 6 from each side, you get 84, and divide by 4, and you have x is equal to 21. In example 4, let's find the measure of ADC. Okay? Well, we know from what we did previously that these two angles are equal to each other because they intercept the same arc. So the measure of angle ABC is equal to the measure of angle ADC. ABC is 10y minus 28. ADC is 7y minus 1. So let's subtract 7y from each side. That gives us 3y here. Add 28 to each side. That gives us 27. And so y is equal to 9. So the measure of angle ADC is going to be 7y minus 1, which is 7 times 9 minus 1, which gives us 62 degrees. Finding the angle measure in an inscribed quadrilateral. If a quadrilateral is inscribed in an angle, then its opposite angles are supplementary. So if we have a quadrilateral inscribed in this circle, A and C are going to be the same, are going to be supplementary. B and D are going to be supplementary. So let's use that to do example 5. So here we know that R and P are going to be supplementary. So the measure of angle P plus the measure of angle R is going to be 180. P is 6y plus 1. R is 10y plus 19. And now we're just doing an algebra problem to find out what y is. So we have 16y plus 20 equals 180. 16y equals 160. And so y is equal to 10. So now we can find the measure of angle P, which is going to be 6y. So y is 10. 6 times 10 plus 1. So that's 61 degrees. The measure of angle R is going to be 10 times 10 plus 19, which is going to be 119 degrees. The measure of angle Q we know is 10 squared plus 48, which will give us 148 degrees. And then if we subtract 148 from 180, because we know Q and S are supplementary, the measure of angle S is going to be 180 minus 148, which is going to give us 32 degrees. And if you add all four of these together, you should get 360. All right, next part, we're going to use tangent-secant and tangent-chord angles to find things. So this is going to go back to what we know about a intercepted arc from an inscribed angle. We know that this intercepted arc is going to be half of the angle measure, and that works the same way here. Measure of ABC is half of the measure of arc AB. So, and this is what happens when you have something, an angle that is on the circle, okay? So, to find measure of angle BCD, BCD is here. We know that the measure of BCD is equal to 1/2 of the measure of arc BC. So we have 1/2 of 142 degrees. So the measure of BCD is going to be 71 degrees. Now to find the measure of arc ABC, ABC is here. We know that the measure of angle ACD is going to be half of the measure of ABC, the arc ABC. Well, the measure of ACD is 90 degrees. And if we multiply each side by 2 to get rid of the fraction, we have that the measure of arc ABC is 180, which makes sense because this is, after all, a semicircle. Finding angle measures inside of a circle. If you have two secants or chords that intersect the interior of a circle, then the measure of each angle formed is half of the sum of the measure of the intercepted arcs. So you're going to define the measure of angle 1 here. You're going to take AB, add it to CD, and then take half of it. So when the angle's inside, you're going to be adding your arcs. And it's important to keep that in mind because you're going to have a similar relationship but different in the next part. So to find SQR, you're going to take 1/2 of the two arcs. So SQR is here. So you have the measure of PT, arc PT, plus the measure of arc SQ. Well, we know what those measures are. We have 32 plus 100. So they have 1/2 of 132. So the measure of, and this should be angle, let me correct that, measure of angle SQR is going to be 66 degrees. Now to find the measures using tangents and secants, you're going to do a similar method, but this time you're going to subtract the arcs, okay? So, and this works for all three of these situations where you have a secant and a tangent, two tangents or two secants. You're going to take the half of the measure of the big arc minus the measure of the little arc, and that's going to give you your angle measure in each of these cases. So, for example 8, we want to find the value of x. Okay, that's going to be our angle. So, x is going to be 1/2 of our big arc, which is RS, minus our little arc, which is QS. The reason you have to do big minus little is otherwise we'd end up with a negative value, and you can't have a negative arc measure. So we have 1/2 RS, which is 174, minus QS, which is 98. And when you do that, you end up with 38 degrees. In example 9, we're going to find the value of x again. Again, x is going to be our big arc, which is EHG, and subtract our little arc, which is EG. So we have 1/2 of EHG. EHG is going to be 360 minus 132, which is 228, minus 132. And so you're going to end up with the angle measure being 48 degrees. So to sum up this section, let's take a look at the three relationships we just talked about. If you have an angle on a circle, whether it's inscribed or tangent, you're going to take half of the arc measure that it intercepts. If you're inside the circle, then you're going to add the two arcs that are intercepted and then take half of it. If you're outside the circle, you're going to take the difference of the two arcs that are intercepted and then take half of it. So this is everything all in one place. So let's do one final example. In example 10 here, we're going to find the measure of AF, which is right here. So let's first of all find the measure of arc ABC, or find the measure of arc ADB, I should say. So to find this whole arc, we have to use angle ABC. So the measure of angle ABC is going to be equal to half of the measure of arc ADB. Okay? So we know that ABC is 110. And if we multiply each side by 2, you're going to get the measure of ADB, arc ADB. It's 220 degrees. Well, we know that the measure of arc ADB is equal to the measure of arc AD plus the measure of arc DB. This is arc addition. Okay? So we know that 220 is equal to the measure of AD plus DB, which is 160. So that gives us that the measure of AD is going to be 60 degrees. And I'm going to actually label that here. So now all that's left is to find the measure of AF. Well, the measure of AF, since we have all the other arcs, is going to be 360 degrees minus the other three arcs added together. AD plus the measure of DB plus the measure of BF. So we have 360 minus 60 plus 160 plus 48. And when you do all of that, you find that the measure of AF is going to be 92 degrees. So you notice we have to do a few things. One, we had to use the knowledge that the intercepted arc if the inscribed angle is half of the intercepted arc. Then we had to use arc addition, and then we had to use the knowledge that a circle makes up 360 degrees to subtract the 3 arcs that we knew to find the fourth. So, good example, kind of pulls everything together. All right, so this section was all about angles of a circle. In the next section, we're going to talk a little bit about segments in circles.